Now D part, sixth part. Yeah, can you just try sixth one? Right, we have studied an equation for pH also, right? You can use this, so you can actually do it.
It's times, wait, so it goes from 8 to 5, which
Mm-hmm.
means it decreases by a factor of 1,000. D for delta again. Is it D?
What? Answer
Is it
C.
D?
I'm sorry.
Is it C? Is it D?
D, D. Okay, let's see. Now we will try to do it properly, then I will tell you the trick, right? Okay, now
Yeah.
what they are telling is the pH of the solution changes from 8 to 5, right? So the pH becomes from 8 to 5, right? So what will happen to the concentration of H plus concentration will change, right? So now let's say I am taking this H plus concentration, right? So I can write pH is equal to minus log H plus concentration, right? Okay, now if I consider the first scenario, right? So here what we have, here we have a solution, and we decrease the pH. So if we want to decrease the pH, what should I do to the H plus concentration? I should increase H plus concentration, right? I should increase H plus concentration, then only the pH will reduce. Can you understand that?
Yeah. Oh, so
Okay,
it'll be C.
it should be C, right? Okay, now pH is
Yeah.
equal to minus log H plus concentration. So if I use it for the first scenario, 8 is equal to minus log H plus concentration. Now I don't know by which factor I increase or decrease the what do you call pH. So phi is equal to minus log. Now I say H plus concentration is altered by x. Now I have to find x, right? Okay, now what I have to do is, this is first equation, this is the second equation. So if I substitute, if I just subtracted the first equation from the second, the second equation from the first equation, it will become 3 is equal to, now minus this one, right? So we have to write like this, minus log H plus, minus into minus, this minus into minus will become plus, right? Plus log
Yes.
H plus concentration into x. Now this is something like this, log x minus log y. So this can be written as log x divided by y, right? So now 3 is equal
Yeah.
to log H plus concentration into x divided by H plus concentration. Can I write this way?
Mm-hmm.
Yeah, so now this is nothing but this H plus and this H plus will go. So x is equal to 10 power 3, right? So H is equal to 10 power 3. So definitely the concentration of hydrogen should have been increased. So I can eliminate this decrease and this decrease answer. D and B can be automatically eliminated. Now by a factor. The factor is what? That is the x. That is the x, that is 10 power 3. So the trick is, when you change the pH by 3 by x, then the H plus concentration will change by the 10 power of that factor, right? So now if you change, now you see here, this is the proper method, but the trick is, now let's say we change pH from one point to another point. So but we are changing it by x, right? So the H plus concentration will change by the factor of 10 power x, whatever the factor we are changing the pH by, right? So if it is, now for example, if I change the H plus concentration from 1 to 2, right? How will the H plus concentration change? Now the difference is 1, 2 minus 1, 1.
Yeah.
So the H plus concentration will change by 10 power 1. But since I am increasing the H plus pH, so the H plus concentration will reduce by this factor, will reduce, right? So the relationship
Decreases.
between pH
Yeah.
and H plus concentration is inversely proportional,
Proportional.
right? Okay, so if you increase pH, H plus concentration will reduce, right? So this is the idea. Right. Do you want to mark anything down here?
Oh no, it's fine.
Okay. Right. So we can move to the next question. Yeah. Right. Can you try the seventh one also? So these are very
Initial
simple
point.
questions, right? We have in
Yeah.
the previous class we discussed some complex questions also.
Mix of 0.8 moles of carbon monoxide and 0.8 moles of hydrogen gas was placed in a sealed 1 liter container. The following reaction occurred. When the equilibrium was established, the mixture contained 0.5 moles of carbon gas. What amount of H2O was present at equilibrium? Oh. Okay. Oh wait, so it just lost. So if it loses 0.3 moles, uh,
Yeah. Okay. Are you doing the question?
the A.
Yeah. A. Okay. So how did you find the answer? So we can use ICE concept. Yeah.
Yeah, if carbon monoxide loses 0.3 moles, that means hydrogen gas will lose 2 times as much due to its stoichiometric ratio, so it will lose 0.6, right?
Hmm.
And then, yeah, 0.8 minus 0.6 is 0.2.
7. The answer is A. Okay. Right. Okay. Now. Here okay, so properly how you should write the answer is you don't need to actually write down the KC and other stuff, right? Okay. So you can simply use ICE concept, right? Okay. We have done a lot of questions regarding this type in the previous class, but this is a bit simple, right? We use even quadratic equations also. Okay, now we will study about isomers in chapter 7, and this is coming under actually module 6, and but we have to study about titration, right? Are you familiar with titration method?
No.
Okay, so we will study about titration methods in the next class, inshallah.
pH lowers.
Now
Yeah,
this
okay.
one is also okay. Right. What about the 12th one?
Industrial production of ammonia is represented by the Haber process reaction shown. Factors such as temperature and pressure need to be considered in order to maximize yield. Which of the following is correct? Lower pressure would result in a higher yield. High pressure would. So you're trying to produce ammonia, and then there's 4 moles of gas on the left and 2 moles of gas on the right. So it's not C or D, it's either A or B. And then, oh wait, no, it favors. It's a exothermic reaction, and then increase temperature favors exothermic reaction favors the left hand side. I think. No, endothermic favors. Is it D?
Okay, let's see. D. Right. So the industrial production of ammonia is represented by the Haber process reaction shown, right? So industrially we produce ammonia using Haber process. Now factors such as temperature and pressure need to be considered in order to maximize yield, right? Okay. Now they are asking, in order to increase the yield, right? So what we should do is, we have to, since this is an exothermic reaction, we have to increase the what is yield here? Ammonia. So if we want to increase yield, we have to reduce temperature, right? So we have to reduce temperature, result in higher yield. A lower temperature reduce the temperature, right? Reduce the temperature. But industrially what is happening is, okay, now you see here, if you lower the temperature only, if you reduce the okay, now this is a statement type question, right? Okay, now what we have studied is, if it is a exothermic reaction, what would happen if you increase the temperature? It will move to the left side, right? So if you reduce the temperature, exothermic, if you increase, it will go this side, right? Okay, now you see what we studied is, if you increase the temperature for an exothermic reaction, it will shift backwards. So C is not correct, and D is also not correct. Why? Because if you increase the temperature, the lower the yield. If you reduce the temperature, the higher the yield, right? So this is not correct. Can you understand that? You should know this, right? So if it is exothermic, what will happen to the equilibrium? It will shift backward. So if you lower the temperature, we will obtain more yield. So this is wrong. And if you increase the temperature, the yield will be lower. So this is also wrong. Now, if it is now we will look at the A and B. Now, if you increase the pressure, what will happen? The equilibrium will move to the direction which we have low number of moles, right? So now we have 4 here. Here we have 2, right? So what will happen? if you increase the pressure only, it will move in this direction, right? So if you increase the pressure, the equilibrium will move to the direction in which we have less number of moles. So what is the answer? B, right? B. Can you understand? Can I just check the answer? 12th one. Yeah, 12th one, B. Okay, so did you understand the explanation now? So if you increase the pressure, the equilibrium will move in this direction, since the product side has less amount of moles, right? So the answer would be B, right? And why is the A option incorrect? If you lower the temperature, not higher yield, right? If you lower the temperature, it will move in this direction, so we will have lower yield, right? So yields are this part, yield, and these are reactants. So the answer is B, not D, okay? Because since this is an exothermic, if you increase the temperature, the lower the yield, right? So this is wrong, okay? Right. Now, 13th one. Can you just try it?